All right. Well, let's jump in. Before I get into the details of this and others, I guess I'll note that you have worked on quite these use cases in, time working with us here at Fraction and before that as well, because you're the CTOs that I know who's probably more time and gotten better with how to use these tools in real life.
Yeah. Thank you. It is the entire machine learning tool set is extraordinarily powerful, and we are just now beginning out what it's good for and what it's for. So all of these use cases are great learners, regardless of whether the decision is to go to models or to use more traditional ML algorithms.
For sure. So I'll start with this sort of like high level. You can check in the X use cases versus sort of more oriented use cases. And this was an interesting and let me lay a little bit found in the course of doing quite a few projects. And also if you read, the literature or, you look at uh, others' work in the field, you'll see this as well. What we found is that there's lots of use cases where effectively, well, you're using the gen in Gen AI, you are generating content, whether that's software, so you're generating code, marketing, so you're generating maybe that's new ad copy, maybe that's actually entire like blog posts or writing, all sorts of things like that. In sales, similarly, maybe you're generating something, as straightforward as emails and things like that, or maybe it's something more complex like an entire proposal. They're great AI powered tools to help with that now. Design, of course, everybody's familiar with Dolly and Stable Diffusion, and there's all of these powerful models for generating images, right? So all of those use cases, so everybody's played with ChatGPT by now, and many of you may be leveraging that and finding success with it. A lot of folks will just scratch the surface and say, its output wasn't that good. There's, absolutely a learning curve to doing a good job with prompt engineering or just even with, successfully prompting and providing the model with enough detail to get good output. But long story short, what we found is across a wide range of industries, using generative AI to generate a first version of something or, an initial starting point that humans then take that. So humans and typically folks that are experienced and senior in their field, again, whether those are senior software developers, senior marketing folks, experienced attorneys, we're hearing this actually even within our client base. We're hearing this from folks who are in those roles. So one gentleman who is a partner at a law firm, and we are helping them build software to manage and accelerate how they manage certain types of cases. And he was telling us that he doesn't know how much they need junior associates anymore because essentially OpenAI or ChatGPT, that's his junior associate now to help quickly write a very rough version of a contract. And then as the skilled, experienced human, he can come in and clean it up and make sure that it actually meets the standards needed to really be shipped. So those are all generative use cases, and we're seeing a lot of success there. Us and tons of other companies too, of course. Review use cases. So why are these like the bad use cases? And so I'll start with an anecdote. Actually, this is my brother-in-law is an interventional radiologist, and he sort of told me this story, but we've seen it be true, uh, more broadly as well, which is that after years of trying, using, lots of models to do essentially image classification or image, recognition to essentially try to read, let's say, to read an X-ray to determine whether or not a patient has pneumonia. That's sort of a simple example. The challenge is not at this point just getting a model to say whether or not an image has pneumonia, whether or not the patient, whose image it is, whose lungs you're looking at. The challenge has to do with the clustering of errors. And here I say LLM errors aren't clustered, but it's an issue in other, in broader machine learning models as well. So if it's let me explain what that means. Let's say that you had a model that could diagnose pneumonia, just taking that one case. And it could do that more accurately than radiologists. by the way, maybe a lot of radiologists aren't willing to admit it, but that's actually already more or less exists. That's not the problem. The problem is that the error pattern isn't consistent. And so it's hard for the humans, the doctors, the radiologists, to know when they can trust the model and when they shouldn't trust the model. That's the key problem. If you could say with confidence that, oh, every time this certain type of pneumonia or this certain type of special case comes up, we know the model's not very good. So let's just look at those scans. Well, that'd be great. That'd be something that you could actually take in and you could use. But if it's the case that the errors are a bit more random, then you end up looking at every scan. And if you end up looking at every scan, well, you just use the radiologist's time on every scan. So guess what? You didn't save any money. You didn't increase productivity. And so these review use cases, which I would characterize as final review. So the same example carries over into law. I was just mentioning the law partner who is using Gen AI to help generate contracts and to do that on the first cut basis, and then he cleans them up. But imagine you inverted that where you had a junior associate write the contract and then you were trying to use AI to finalize it or say that it was good or not. Well, then you run into that same problem where can you really trust it as being your final line of defense? And so that's why review use cases we found that when folks want to see that, that's where it tends to fail because the human reviewers, people who have to put the seal of approval on it, don't have that degree of comfort yet that they can put their own professional, liability on the line.
Yeah, and
So
we've seen that quite a bit. As we're looking at using models, large language models for people, what we run into is in these industries where people are used to large stratification statistical models that you can follow the variable and it's completely grounded, so you know exactly where that information came from. That drives the trust. Today,
right,
because LLMs kind of feel like voodoo to many people, there's that trust gap that doesn't let us
right.
trace back to I can pick the piece of information that made me draw this conclusion. Now you can do that with LLMs. It just requires some grounding work that people are just now getting used to doing. So
Right. No, that's a really great point, Jeremy, that explainability aspect. And in fact, the last company, my startup before Fraction, Hidden Levers, what did we do? We did portfolio stress testing and risk analytics. So we were in the finance world building applications against that. And we were using technology that predates modern machine learning and predates LLMs. I mean, this was before, of course, ChatGPT and these things were even released. Uh, but why even today is the finance industry still a little resistant in some ways to using LLMs? And part of that's to do with explainability. With a model that's based on, statistical analysis like regression analysis or like principal components analysis or other models like that, you can point to saying, well, the model says that this stock is going to underperform because of X, whatever data point that it was looking at, or the model believes that in this scenario that interest rates are going to rise and therefore these investments are going to be impacted in this way. Again, you could point to specific factors like that, and financial advisors that were our users in that use case, they liked that explainability. You could have a more accurate model that was LLM based or that was based on machine learning, but they wouldn't be able to use it because they couldn't explain to their end customers, the clients, well, why is it saying that? We're not really sure, but it's usually right. That's not good enough. So anyway, so that's why when you think about generative versus review, and if I jump in a little deeper, this really blends into this sort of next statement, which is semi-automated workflows for the win. What I mean there is rather than trying, like we get a lot of clients that come to us and there's sort of this idea that, like, oh yeah, AI is magic. So it feels magical. And honestly, it does feel magical. But it's this idea that, oh yeah, we can automate XYZ. And of course, that's the right frame of mind. That's the right thought process. But rather than trying to automate 100% of a workflow, if you just manage to automate 50% of the human effort, well, guess what? You've doubled your productivity or halved your costs. And if you manage to, get to 80%, from 50 to 80 is huge. Now you're at 5x productivity. So that's really where the meat of the gains are and what we've seen in practice, listing a couple examples here, and I can dive into, some of these companies specifically in a moment. But when you stop trying to reach for perfection and you start out like with your initial goal being, okay, here's a workflow. It's got 12 steps in it. Can we automate this such that, 4, 5, 6 of those steps are now automatic and now the human doesn't have to be deeply involved, but they're still involved enough that, okay, maybe 6 of the steps are automated, but because they're involved in the workflow, they can check and clean up any issues that arise.
Yeah, and that can really drive some process improvement, some time to market, and speed of delivery for things, as you start to use these tools. And it's classical process improvement, right? Take away the rote, boring things that human beings do, and make the human beings focus on what human beings are really good at, and provide the decision support and provide the assistance in that workflow to increase labor productivity. It just so happens that AI and generative AI are really good at it can be really good at that, because it becomes sort of a conversation between the human and the machine, which is the whole idea of the prompt, right? But you can refine your work with that machine in ways that we couldn't do before, with other workflow and process improvement tools, because they were very strictly static and configured, where these large language models can react to changing questions and things in such ways that make it more natural for a person to interact.
Yeah, and the error tolerance is higher, so you can send in data which is sort of like semi-structured or not well formatted. And let's just say, for example, you need all of the addresses that are in some document or something. It'll do a pretty darn good job of finding all of the street addresses in a document. And should you be wary of hallucinations and things like that? Well, it turns out if you dial your prompts in and do some of those things correctly, then you can actually, with narrow questions like that, get a higher degree of accuracy, honestly, than you used to get from the static tools that would just miss data entirely. They wouldn't hallucinate anything, they would just miss because, like, oh, the code, the rules didn't account for the punctuation being exactly in this way, or the carriage return, the
Right.
line break being right there, that sort of stuff. If I jump in, like, just to mention quickly some of these examples. So Advisor Brand Builder, which if you look the company up, you'll see their tool out there. So what they did was they wanted to automate the process that actually the owners, that their own company does. They are a marketing and design firm that focuses on financial services firms and financial advisory firms. And so Advisor Brand Builder was intended as a tool where a financial advisor that is, say, spinning up their own business. So a lot of times you have financial advisors that will leave a major firm like a Merrill Lynch or a Morgan Stanley or a Goldman Sachs, and they will start their own firm, and they'll bring a lot of their clients with them. So they need a brand all of a sudden. They don't have a logo, they don't have a firm name, they don't have anything. And so with this tool, there was an entire workflow where the advisor could either enter or speak out, like, what is the sort of, mission and philosophy and ethos of their firm, and provide a lot of other information like that, around what do they like from a branding aesthetic perspective, stuff like, what car brand do you like, and sort of answers like that would help drive into the output. And so what this tool would actually output is a lot of the copy needed to build a new advisory firm's website, and an initial sort of V1 logo and sample color schemes that could be selected from it. Again, back to this whole idea of cutting human effort by 50%. Where they ended up was with a tool that enables the human designers at this firm called Intentionally, that owns Advisor Brand Builder, uh, enables them to just spend a couple of hours to tune the brand, and then all of a sudden it's shippable and ready to go, instead of that being a really time-consuming process of sitting with that new client and getting all the information from them, and then ideating and thinking through what this new brand should look like. So taking, I don't know, something like 20 hours of work and shrinking that down into a handful of hours of work, something in that neighborhood, is what became possible. So that's a textbook example of getting first maybe 50% productivity improvement, then getting toward 80% and achieving, a lot just through that process. With some of these other ones, whether it's generating sort of messaging for in this case for realtors to be able to message to their clients. We were talking about I was talking about a financial use case earlier. So while, financial advisors, investment analysts, all sorts of people in that world may be wary of models that they can't explain, you can still use LLMs to take results from sort of more standard models and add the language around it to explain to a lay person what it means. And so you can create, whether it's financial chatbots, real estate chatbots, legal chatbots, you're starting to see in all of these different verticals, what the large language models are doing is really having the conversation with the human and helping explain all of this data and insights that sometimes the actual underlying data still comes from the same more old school, what we call deterministic, but models that give you the same answer every time. So they're not sort of hallucinating. They're simpler, but at least they've got that level of reliability. And here we just use the large language model to help convey that to humans in English or any other human language.
Yes.
So, Jeremy, I'd love to hear your thoughts on this. I think that the best use case, honestly, is in our industry. It is code generation. And I have to admit that I learned a lot from Jeremy and how effectively he was using these tools. So, yeah, walk us through your process or what
Yeah,
you've
yeah.
seen.
It is actually one of the best use cases right now is for coding work, and I always kind of have this thought that really, really good technologists tend to be lazy, and they don't want to, type the same thing over and over again, and they don't want to memorize, function names and things, or look it up in a big book. And so, one of the great advances in the past few years it is the idea of all of these tools that are now helping us drive code creation. And I started using it uh, pretty as early as I possibly could, simply because uh, the promise of being able to essentially explain what code block that you want, what do you want it to do, an AI generating it, and then your job is just to basically peer review that AI and make sure that it makes sense and it's not doing weird things and so on and so forth. And you can go everywhere from saying, create me a API call that will reverse the letters in a string, and and it will generate that for you, and you can build it out in the language of your choice. You can tell it what framework to use. And as you get used to doing that, and as that particular copilot or cursor or whatever tool you're using starts to learn coding style and learn what you're doing, it gets more and more seamless in the trust factor, and it gets more seamless in you start typing and it finishes the entire block of code for you. And I use this a lot, and it has increased my productivity because I am a slow typer. So it increases my productivity by multiple factors, and lets me create cleaner, more concise, and quicker, higher quality code than I used to be able to do when I was using VI and Emacs and things like that. So that is just an amazing piece, and it actually gets kind of creepy sometimes, because I'll start to type something and it'll throw out a block exactly as I would have written it, because it'd been watching me code for months and months and months and months,
Right.
and has been learning my coding style. So it will create those blocks exactly as I would have written it, and it's
Mhm.
creepy because it's almost like, oh, the computer's now reading my mind. But if you really think about it, that's exactly where you
Mhm.
want to be, because that's when it really starts to accelerate your productivity. Because again, now we're to this repeatable stuff that a computer can learn from enough data to now I'm concentrating on the real problems of performance, or cyclomatic complexity, or whatever piece you want to focus on. I can focus on that because I don't have to type as much.
Yeah,
Is
no,
the
for
simplest way
sure.
to put it.
Yeah, and I think that well, from a, fraction standpoint, what we started to see was Jeremy, how productive that you were able to be with these tools. So then I jumped on the bandwagon and really started to use Copilot mainly, tried out some other tools as well, but in writing code. And what you realize, so this is the I would say the learning that we had from that. One is that from an accuracy standpoint, these models are better at generating code than they are at generating human language. There's some simple reasons why. One is there's simply less words. There are less possible, although uh, it should be said that programming languages are Turing complete, which is fancy speak for you can express any thought you can express as a human, you can also express in code. Might take a little bit more code than it would take, English words or something, because you have less words that you can use, but you can get there. And so you can express any thought, but because code has to follow certain strict rules, a lot more rules than when we're just writing free form language, that's one thing that makes it easier in the fact that you've got this thing called a compiler. Like the code has to follow those rules or it simply won't function. So there's those guardrails that the model can work within. But what we found, just like with all forms of prompt engineering, is that it's not immediately intuitive to engineers how to ask the machine to write what they want. And so there is a learning process for developers. And a lot of developers will get frustrated after writing a quick one-liner, like I'm sure a lot of you have tried, in ChatGPT, and you get like a less than satisfactory response. So the interesting sort of, and this is positive for code as a whole, the interesting thing is that the more detail you give in the prompt, the better the quality of the code output you'll get. And that also is precisely what you ought to be doing in terms of comments that you see in code, which help to document what it is you wanted to do in the first place. And so those two kind of they really dovetail, and that's a positive overall for the quality of your code. We started testing engineers, to see if they already had picked up on some of these, skills in terms of how they use Copilot and generative AI starting early this year. And what we found, and we've done some measurement of productivity gains, the AI alone can as much as double productivity, for a good developer. What we're seeing though is if you take the AI capability and knowledge of how to use it well, and you pair that with someone who's already a senior architect or like CTO level or almost CTO level, well, then they're bringing a lot of human skill to the table. So those two together lead to like 4x productivity relative to a rank and file individual contributor that is maybe a senior engineer, but who doesn't bring both the holistic thought that someone who's had to be in that senior role brings to the table, and then also the ability to use the AI. So that 4x productivity gain, and I think, Jeremy, you're absolutely an example of someone who's doing that. But we've seen lots of folks. We had an engineer who's quite senior who knocked out an MVP actually of a very interesting tool, which is doing real-time analysis of legal cases. So calls about car accidents or other types of personal injury. And it's real time listening in on the calls to qualify whether or not they're good cases for the attorneys to take. So that's an example, and that's a proof of concept and an MVP that's been built out. And I think the gentleman that we have working on it in like 6 weeks, and he's almost done. And so that's really impressive work, and that's part of that. The secret behind that is using these tools. All right. Well, last but not least, I didn't want to forget, Jeremy, the fact that non large language models, so traditional machine learning, you were mentioning the other day a really cool use case
Yep.
Around microfilm and the use of traditional kind of machine learning, or what we used to call AI, to do that. I think that the context that I'll set here is that it's more accessible than ever for engineers to use. There's tons of great open source models. If you guys aren't familiar with Hugging Face, it's this big website that's become super popular, or a company, that helps to promote all of these open source models and share them. And so, yeah, so there's so much out there. So yeah, take us through, an
Yeah.
example like this.
Yeah. So, and this is one of the things that right tool for the right job, right? LLMs are hot right now, but using non-generative AI is still a really great thing to do. So there's a company that we work with that basically takes obsolete technology and digitizes it, makes it available for their customers. And some of their customers happen to be state institutions, um, colleges, and county institutions, and they have a lot of stuff sitting around on microfilm. And For those of you that don't have as much gray hair as me, microfilm, it was a way for the early digitization of paper. So you could go find a microfilm of 10 years of paper documents and run it through this machine that usually made me kind of motion sick. I don't know if anybody's ever used a microfilm reader. It'll make you motion sick. But anyway, so the idea is those are completely obsolete. Nobody has any of that stuff. So this company that we're working with contracted to digitize a microfilm. And the interesting thing is every page in that microfilm has a marker on it, but the marker is in a different spot, and it tells you what document it is, what page it is, what page of how many pages it is. But they're in different spots. Sometimes they're handwritten, sometimes they're stamped, and a little bit obscured by other text. And then the other is that at the end of each document, there is a marker page. Same deal, though. It was just a blank page that somebody stamped or wrote on that said this is the end. So the application of ML here is very interesting because it's a computer vision application where we're taking the microfilm, we scan it, and we run it through an optical character recognition algorithm called Tesseract. It's a pretty good one. And we extract that data, and then we run it through a computer vision model, vectorize it so that we can find these markers and tag the information in the pages, and then rename our files so that you get entire books in a mostly automated fashion. To our earlier discussion, though, there is a QC process. It's not a review process. The model found that it's ambiguous, and we have it set for below 80% right now. It's ambiguous, so a human being has to look at it. So the way that makes the human more effective is they're now exception-based processing these things that the machine just throws their hands up at. And if we can get 80-20, 90-10 of automation versus things that need to be checked, suddenly a very few number of people can do these 90,000 rolls of microfilm in a much shorter time. So it is really an interesting application for more traditional non-generative ML.
Yeah, no, it's a cool use case, just an example, a reminder, that traditional machine learning, whether it's computer vision, but even, there was another project that we were working on just as an example, which was doing analysis of different ad campaigns and sales on Amazon. So this was a company, actually the startup that was building software to help brands manage their sales of over-the-counter products, over-the-counter, both drugs and also, other brands. It could even be like sports drinks or anything that goes on a shelf in a pharmacy or store. And they wanted to, well, analyze, okay, for their online channel, for the sales on Amazon, for their clients, which ads are doing well, which ads are doing less well, and, sort of all sorts of analysis around that, like based on time of day of week, all sorts of other factors. And so using a traditional machine learning model to actually do that analysis makes more sense because if you feed that kind of data into an LLM, that's where you start to get hallucination out the wazoo because it's a little bit too much in terms of just, essentially vast spreadsheets of numbers. And that's not the kind of information that these large language models were trained on in terms of being able to make sense of it. Actually, what ends up happening, so you can, if you've ever tried this, like on ChatGPT, the premium version, you can begin now to work with spreadsheets and stuff like that. Some of the tricks that they're doing there are that they're feeding the actual spreadsheet data into underlying code to help break that down and feed it back into the large language model in a way that it will do a better job of answering. And so sometimes you have sort of symbiosis between other forms of machine learning or regular kind of quote unquote regular code, I guess, and the large language models. But anyway, so these tools, the reason that I like to bring them up, or I want to make sure we bring them up here, is that they're easier, they're more accessible than they used to be. This used to be incredibly expensive to get folks who knew these machine learning techniques. It's more accessible. Certainly within the fractional model, we have talent that has the skills to utilize it. But even just for your own teams, for what you guys are doing, getting on Hugging Face and looking at I don't know if they're up to 1 million, but the hundreds of thousands of models that they have available. There's so much out there that can help attack these problems. All right. Well, I think we're at time, so I'll leave it there in terms of takeaways. These are just sort of the highlights. But if anybody has any questions at this point, happy to take them and expand on any of the areas we've been talking about. And if not, just by way of sort of the takeaways for you guys, as you can see here, what I'll just highlight is the idea of there's always this notion of don't let the perfect be the enemy of the good. But in this LLM or this Gen AI world, that's take a workflow that you were thinking of trying to automate and, work on the low hanging fruit there, make it semi-automated, keep the human in the loop, but make the human more productive. That's a better goal to reach for and where we've seen success, as opposed to trying to fully automate certain processes where then your quality may slip to levels that aren't acceptable. So that's one. The other is if your developers aren't using code generation, whether it's Copilot or many of the other tools that are out there, they need to be. And if you're detecting resistance from your folks in that regard, I think that's something to look at. We're focused on only working with developers that are leveraging those tools to be productive. So I think that there's so much going on, so many ways that you can succeed with this technology. But if you get your teams to start by just using it to help them generate code, well, you're having success right out of the gate.
Yep. And then Jonathan did have a question. He asks, are we seeing more adoption with small language models versus LLMs? And I'll take a stab, and then Praveen, what
Sure.
you've seen as well. I am seeing increased interest in small language models, and the use of them makes a lot of sense in certain niche areas. One of the things, though, is there is more setup ramp time for small language models. Often you have to train them yourselves and so on, where large language models are pre-trained. And one thing I would suggest is try doing techniques like RAG, and which is retrieval augmented generation and so on. Before going all in on a small language model, unless you have a very specific use case where that makes sense.
Yeah. No, what I'd add to that would be to say that where we've seen success is for the MVP or the V1, unless you have certain hyper-specific privacy concerns, go ahead and use, OpenAI, or I don't know, maybe use Claude or, one of the other commercially available APIs, because it's just so easy to move quickly with those. Your developers ought to be able to integrate that, or team ought to be able to integrate that inside of a day, to just get it up and running and answering some basic questions and then iterating from there. And if you have success at that level, then you can start optimizing, because it may be the case that you're calling so much that all of a sudden your bill is blowing up. That's when you can start to look at bringing some of those capabilities in-house examples of that would be, so Jeremy mentioned, RAG approaches. Well, you might take one of the models off of Hugging Face, and there are a lot out there that you could use to do the vectorization. So to actually feed content in that may be related to your application and create vector embeddings out of those. And so what is that? That's basically taking a block of text and turning it into a really long number, for lack of a better word. And what that represents is the sentiment, or like what the machine understands about that snippet of text. And so what that enables is that you can then search. Like, so if you take like all the documents you have in your knowledge base about some system, well, you could vectorize all of that content. So breaking it up into little chunks, maybe a couple sentences at a time. And then you could have a search application where the user types in a search, and instead of just searching on keywords, you can actually search on the meaning. Like, what was the meaning, the sentiment, the meaning of their question, and which of these blocks of text actually matches that meaning the best. So that's the essence of RAG that we're talking about. And but you can do some aspects of that processing using off-the-shelf models to help you lower the cost of making all of the calls. And so that's definitely something that we've seen where teams will use those components to do that piece, but then for the final analysis, they might still call OpenAI and or one of the big models to help with that.
Yeah, and another use case where an SLM might can come in handy is that idea of they can be more cost effective. You can often run them on less expensive hardware, but they are more limited in the sense of the outputs and the outcomes that you would get. So also, if you have a use case of maybe an edge AI case where you're trying to stick something out in a small device or a low power device, an SLM, of course, it could be useful there because you can run it locally as opposed to having to call back to a large language model.
For sure. And, when you get to that point, so I think that in terms of like iterative development, when you get to that point where, hey, you're having success with a large language model, but then then you're like, oh, but if I could just train this model beyond what's possible with just fine tuning or some other approaches, then would it be that much more accurate? And then that becomes your V2, where you actually get into the weeds and you start training. You take, maybe you don't take a small language model. Maybe you're taking something that's a reasonable size, like a llama or one of the open source models, and adding training data there, essentially fine tuning a model like that. But then again, that's something that you can control in-house. The only other use case where we're seeing a lot of interest in this, where it's like, okay, we don't want to use OpenAI, or we can't use OpenAI, or one of those, or Anthropic, or Gemini from Google. That would be where there's security reasons that you can't send the data outside of your walls. Mm-hmm. And so those would be use cases where you don't have a choice and you actually, need to bring the model in-house from day one.